Okay, page 2 of compound interest. Number 3, Brenda invests $5,000 into an account that offers 3.4% interest compounded annually. So the interest, which would be R or I, is 3.4%. Compounded annually, that means K is equal to 1. 5,000 invested, which would be PV equals 1,000. I'm sorry, 5,000. And calculate the amount of money that Brenda has in the account after 6 years. So N would be 6. So if we were going to put that in the equation, it would be FV equals PV times 1 plus R over 100K to the Kn. So here we don't know FV, we do know PV is 5,000. We know that R is 3.4 over 100, K to the N. Okay, and then we can use the calculator finance package to do that, TVM solver. So we'll put that N is 6, and we'll put that I is 3.4. The present value, we could say that we put it in the account so it left our wallet. We could say it's negative 5,000. The future value we don't know. Compoundings per year is 1. So let's see what the future value is. It's going to come out to be a positive number. Alpha, enter. It's going to be 6110.73. Okay. Luke also invested $5,000 into an account that offered R% interest compounded annually. After 6 years, he had $62.50 in his account. So Luke had an account where he also did 5,000, and the future value in this case we know is 6250, and it was also compounded annually. So they want to know what's N. So in this case, we know FV, so we type in 6250 in for FV. And the interest rate we don't know. It's also 6 years for N. I think N is already 6. Yeah, N is already 6. So then we're going to go out to the interest rate. We don't know the interest rate, so we're going to say solve that. Solve for the interest rate. It gives us 3.79. So the interest rate is 3.79. Okay? All right. Number 4, Hussein invests 20,000 EGP in a bank that offers a rate of 3.1% compounded monthly. So what do we know? We know that present value is 20,000. And we could say it's, in the calculator we can say it's negative 20,000. For the rate is 3.1%. Compounded monthly means K equals 12. The amount of money that Hussein has in the bank after 5 years, N equals 5. So we have FV equals PV times 1 plus R over 100 K divided by, or to the power of K N. And then so PV is 20,000. And it's multiplied times 3.1 times 12 times 100, 12 times 5. Okay, so we're going to put our data in the calculator. It's going to be N equals 5. I is 3.1%. PV is 20,000. And we're going to put negative 20,000 to indicate it's leaving your wallet. Future value, we don't know. K is compoundings per year. We put 12. Okay. And then we go up to the future value, which we don't know yet, and we're going to put alpha, enter to solve for it. And it gives us 23,348.49. 23,348.49. Find out how many years that it will take for his money to double. So you can see that he started with 20,000. After 5 years, he had 23,000. So how long would it take for him to get 40,000? So if the future value was 40,000, how long would that take? So right now you're solving for n, right? So 1 plus 3.1 divided by 12 times 100, and then the exponent is 12 times n, and we're going to solve for n. So we'll put all those numbers in here. N is, we don't know. I is 3.1 still. PV is still 20,000. FV, we're going to put 40,000. 40, 1, 2, 3. Because we want double. Why don't we put negative 40,000? Because in this case, the present value is negative 20,000. It's leaving your wallet. Future value is positive 40,000. It's coming in at the end of the period. How long is it going to be? We don't know. So we'll go to n and we'll do alpha, enter. And it'll give us 22.4 years. 22.4 years. Okay. All right. Number 5. Minura invests 50,000 SGD in an account that pays 7% interest per year, compounded yearly. Calculate how much she will have in her account after 3 years. So the present value is 50,000. When you put it in the calculator, maybe you put negative 50,000 in an account that pays 7% per year. So interest is equal to 7%. Compounded yearly means k equals 1. Calculate how much you will have in your account after 3 years. So n equals 3. So that would look like this. Future value equals present value 1 plus 7% divided by 100 times 1. And that's to the power of 3. So n is 3. Interest rate is 7. Present value is 50,000. Future value is we don't know yet. And the compounding is 1 per year. So we go to the future value and press alpha, enter. And it gives us 61,252.50. So that's after 3 years, that's what she has. The bank then changes the rate to 6.8% per year, compounded monthly. PA is per annum, which just means per year. So compounded monthly, now they're going to change the K value to 12. And they change the interest rate to 6.8%. So calculate how much she'll have in her account after 3 years. Okay. After another 3 years. So you could use n equals 3, but now you have to make sure that the present value is going to be 61,252.15. You can't put the original. You can't put the original amount there because for the first 3 years the rate was 7%. Now it's going to be 6.8% with k equals 12. So the present value we're going to change from 61,252.15. Oops. 0.15. Oops. There's got to be a second. Insert 6. Okay. Interest rate is now going to be 6.8%. It's going to be 3 more years. And the compounding per year is going to be 12 instead of 1. And then we're going to calculate the new future value, just 3 years after that. It's going to be 75,070.16. Okay, that's it for this problem set.